everyone, welcome to Unify Study. How are you all? So in our last class we did the functional dependency and normalization. So in this class, as I promised that yes, I am going to explain the lossless, lossy and dependency preserving and the remaining topic also. So these things we will discuss today. So here we will discuss the remaining all the topics we have discussed in our last class. Those who did not watch it or you missed it, I will suggest you definitely watch that. How to identify functional dependency, how to identify normalization, candidate key, these all the things we did yesterday only. Okay, so now today I am going to cover mainly the dependency, lossless, lossy and dependency preserving. After that, other topics also from where questions are coming, like relational algebra, ER diagram. In DBMS, if you are thinking DBMS, mainly the concepts are coming, means three chapters are most important chapter. First chapter is functional dependency, normalization, key, lossless, lossy, this. After that, next topic is ER diagram. From the ER diagram, multiple questions are coming. Next chapter is relational algebra and SQL, and another chapter is transaction and concurrency. These are the 4 chapters from where minimum to maximum 10 marks you are expecting, and every year, every time they are asking comprehension type question, mostly from DBMS. That's why this DBMS is a very, very important subject. Whatever exam you are preparing, UGC NET, GATE, ISRO, SET, PhD entrance, PSC, whatever, for every exam this is very, very important, right? Now here I am going to directly, these questions to already be discussed yesterday, right? I hope it is clear to you all and there is no doubt you will be able to solve all the questions. Now, can you tell me what is the answer for this? If you know that, that's fine. You can let me know in the comment section. And those who don't know, for them, I will explain that lossless, lossy and dependency preserving very clearly. After that, you will never forget this concept. It is my promise. Okay. First of all, lossless. Lossless means there is no loss. Loss, why the loss is coming? Here the loss is coming because, just think it once, ki there is mother, father and between there is a kid. Mother, father, kid. This is a family. Okay. This is a family. Now mother and father, there is no understanding. That much understanding is not there. Answers are coming. I am explaining. After that I will tell you what is the correct answer. So for lossless, this concept will be very clear to you. Here you can see mother and father, they are always fighting, and that's why there is no understanding between them. And that's why now they are going for separation. They are going for separation. So that's why now this was a complete family. This was a relation. Now this relation separated into 2 parts, R1, R2. Now in R1, mother, father separated. Mother and father separated here. Okay. Now in between there is the kid. Kid is the common person. Kid is the common person. So either maybe kid sometimes staying with mother, sometimes staying with father. As this kid is the common person here, this kid is the common person here. That's why there is a chance that this family can join again. Is it or not? In movies also you are watching, right? क्या सब मूवी है कि अकेले हम अकेले तुम, ऐसा एक मूवी है ना कि there was a kid, so that was a very long back ago, अकेले हम अकेले तुम, ऐसा कुछ एक मूवी था. तो जहाँ पे वो kid था, वो kid है common person, right? So this kid is trying to join the family always, as this kid is the common person. He or she is able to, because why? If the kid is able to convince the mother that yes, please join, I am not feeling well or something, or if the kid is able to convince the father, either this or this, if it is happening, then they will join together again and they will make the family. again, that is a lossless join. This is called a lossless join. So what is the meaning of lossless join here? The meaning of lossless join is happening actually when a relation is there. In this relation, if you are dividing in R1 and R2, then main one formula is coming like that. R1 intersection R2, R1 intersection R2 implies R1 minus R2, or R1 intersection R2 implies R2 minus R1. This is here where you are getting confused. It is actually the kid. What is in the intersection? In the intersection between the kid is here. That's why I am telling kid implies mother. R1 minus R2. What is the meaning of R1 minus R2? If I am taking here A, B, C, and here is AC and here is BC. So ultimately intersection in between them, the C is there. C implies R1 minus R2. R1 means AC minus BC. Always C will be cancelled here. This is the common property. Whenever you are doing minus from set 1 minus set 2 means first one minus the common one. First one minus the common one. So means you are getting here whenever you are doing AC minus BC. Okay. Oh. So whenever you are doing this ABC, here is AC and here is BC, and this is R1, this is R2, and this is the relation. So what I told, R1 intersection R2 implies R1 minus R2. One set minus another set means it is actually from the first set you are doing minus the common part. Means R1 minus R2 means intersection is the C. C implies R1 minus R2 means BC minus AC minus BC. AC minus BC means it is A. Or R1 intersection R2 implies R2 minus R1. That means here it is happening C implies B. So either this or this, if any of the functionality present, then it is called lossless. Means the common person is there between them, R1 intersection R2, this is the common person. It is able to convince. So either C implies B should be present or C implies A should be present. If any one of them is present here, then we can say it is lossless. So kid is the common person who is able to convince either mother or father. Then they will be able to join together, means it is lossless. If there is no common person, if R1 intersection R2 is 5 here, there is no common person. If they are 5 means no common person is there. Then you cannot say it will be joined, nothing. It will be 5. Like that, only 2 person is there, husband and wife. They are separated now. There is no common person. They will never join. It's completely separation. It's completely going for divorce. Okay, there is no chance to join them. Because there is no common kid, no person is there. No, anyone is not there to join them. Someone should be there to join them. That's why if it is 5, it will be definitely lossy. If there is any common person, then also we can't say it will be lossless. It should convince. The common person means the kid. Kid should convince either mother or father. Means either R1 intersection R2 implies R1 minus R2 or R1 intersection R2 implies R2 minus R1. This should be present. This intersection implies this functional dependency should be present. Then only we can say it is lossless. And that's why in this question, as you can see, what is happening here? This A, B, C, D, you have divided like this. A, B, B, C, A, B, then after that you are getting B, C, then after that you are getting B, D, right? Now you can see what is the common here? B. B is the common. You have to find out that B implies A or B implies C. Any of them is present here. Out of this functional dependency, you have to see any one is present here. B implies A or B implies C. Yes, B implies C is present. Means here B implies C is present. That's why, and here A implies B is present. But B implies A is not present. But okay, B implies C is present. That's why you can join them together as ABC. You already joined them together. After that, again in between them, you can see this is BD and this is ABC. Common is B. Now you have to find out B implies AC or B implies D. Any one of them is present or not. Now you will see here, if B implies AC, can I get it? Just do the closure from here. It is the easy way. What is my requirement? My requirement is B implies AC. I will do the closure. B implies, if I am getting from here, B to C, C to D, D to B, A is not coming. So A is not possible. But from the B, B to D is coming. In the closure, I can see B, C, D is coming, means B implies D is present. It is hidden. Although it is not given in the dependency, but by doing closure, I am able to get B implies D, means this is present here. As this is present here, that's why you will be able to join them together as A, B, C, D. Means they are again lossless. That's why this is lossless. This is the best way to solve. Conventionally, if you are doing, you will do that. Okay, here is A, B, C, D. After that, you will do here. Okay, I am getting here A, B. After that, B, C. After that, here I am getting B, D. You will divide them. It is A implies B. This is B implies C. This is I am getting B implies C. After that B, D, right? I am getting here D implies B. And here you will do all the closure. You have to find out all the hidden dependency by doing F plus. It is a time taking one. But I am telling you to do the backtracking. It is the best way in exam hall. What is my requirement? My requirement is that I have to find out R1 intersection R2 implies R1 minus R2 or R1 intersection R2 implies R2 minus R1. This is my requirement. According to my requirement, if this is not present in given dependency, I will just do the closure and I will check it is coming or not. If it is coming, then fine. If it is not coming, then I will say it is lossy. Is that clear to everyone? Clear? Yes or no? Tell me. Is it clear? Reply once. Not coming. Okay. I hope it is clear. Now I will go for dependency preserving. If it is clear, then tell me, then I will go for dependency preserving. Same way, backtracking way, you can solve the dependency preserving. Yes? Okay. Good. Very good. So now I am going to dependency preserving. Dependency preserving also same way. Here this condition is not there in dependency preserving like R1, R2 or R2, R1. Dependency preserving means nothing else. Whatever dependency is given to me, always remember one thing, hidden dependency you have to find out for doing lossless, lossy and dependency preserving both. This is main important thing. So the functional dependency F will be given to you, that is this FD for a given relation. You are dividing the relation into 2 part, 3 part, whatever, R1, R2, R3. Always from here do the FD closure. Means all the hidden dependencies try to find out by doing the closure. After that divide them in F1, F2 and F3. Then you see that by doing union am I getting back my original one? If I am getting back my original one, means it is called dependency preserving, as simple as that. If I am getting back, then it is dependency preserving. Okay, so then here in this question, is it dependency preserving or not? Check it. In this question, directly do the backtracking. Easiest way to do the backtracking. What is my requirement? It is I am getting or not. A, B, C, D. When it is divided into 3 parts, R1, R2 and R3. This is AB, this is BC and this is BD. You have divided into 3 parts. Now you can see AB means I will get here A implies B. And BC means this A, BC is coming here, that is B implies C. And BD means D implies B. Okay, now see the problem. Try to find out the problem. Problem is creating this one. You will think that okay, after joining I will get back A implies B. I will get back B implies C. I will get back D implies B also. But I am not getting back C implies D. This is creating problem ki I will not get back C implies D. That's why you will think that it is not dependency preserving. Don't do this mistake. Because here some hidden dependencies are there. See that C and D is not in a same table. Now you have to think in opposite way. Using transitive property, can I get back C implies D? Anyhow. Here BC is present, here BD is present. Think opposite way. Here BC is present, here BD is present. So if I can find out the functional dependency like C implies B and B implies D, by transitive property I will get C implies D. Always think in opposite way. This type of questions are always coming. This is I am not getting directly. Now indirectly I will try to find out. My target will be, can I get C implies B and B implies D? If I am getting, then from the transitive property I will get back C implies D. So now see how we will check. Just do the C closure. From the given dependency, do C closure and check it ki C implies B is coming or not. Okay? Yes, here you can see C closure by doing CD, D to B, it is coming. Means from here I can say C implies B is present. C implies B is present here, right? So you can see that yes, C implies B is present. Now I will think B implies D is present or not by doing B closure. B to C, B to C and C to D. That means D. Means from here also I can find out B implies D is also present. B implies D is also present. Means these two was hidden dependency. C implies B and B implies D. These two was the hidden dependency. As these two hidden dependencies are there, I am able to find out. Means from here by doing transitive property I am getting back C implies D. Means this is dependency preserving. That means after joining these all I will get back the original functional dependency. Means it is dependency preserving. In the list I am getting here A implies B. Here I am getting B implies C and C implies B. Here I am getting D implies B and B implies D. Now from these two actually I am getting back. C implies D, C implies B and B implies D. From these two I can get back this C implies D. That was my target. I am getting back means it is dependency preserving. Is that clear? Yes? Clear? This is the trick of doing this type of question. This type of question always coming like that. There should be some hidden dependency. You have to focus on hidden dependency. By finding the hidden dependency, you can say, yes, it is lossless or lossy. Same type of question, this one. Now you can easily tell me what will be the answer for this. Same type of question repeated again. This is now easily you can tell me the answer. PQRS. P implies Q, Q implies R, R implies S, S implies Q. PQ, RQ, SQ, same type of question, only they change the, instead of ABCD, they put here PQRS. Now tell me what is the answer. Everyone can answer, right? See that you are able to understand or not. Now you will be easily able to answer. Definitely this is also dependency preserving and lossless. Same way you can solve. Same way, right? Yes. Yes. Hi Pranav. Hi. Now do this one. Now do this one. Yes. Very good. Now do this one. This is another type of question where ultimately you have to find out first dependency. Here they provide the relation and from the relation you have to find out dependency. Then you have to answer. This is the main thing here. They will not provide any dependency. You have to find out dependency. Then you have to answer it is lossless, lossy or invalid or what. That is you need to find out. Tell me, is it possible? Can you find out the dependency or anything? Yesterday I thought, yesterday we discussed how to find out the dependency present or not, it is valid dependency or not. Yesterday I told you, right? Okay, answers are coming. Very good. Option A is the correct answer. Those who are telling they are correct. How the option A is correct answer? Here you need to think. Backtracking. Backtracking is the ultimate concept. Here whenever you are getting R, it is given A, B, C, D, E. Right. You are able to divide them. R1 is A, B, C. Now R2 is given a little bit space, so let me take the space. Here is R2. R2 is given here. One only R2 is there, nothing else is there. Only R2. Put here R2. R2 is C, D, E. Now what is my requirement? To get the lossless or lossy, I need that what is my intersection point, that is R1 intersection R2 implies R1 minus R2 means here ABC, here CDE. What is the common? Common is C. C implies R1 minus R2 means ABC minus CDE. Between them common is C means AB is remaining. That means C implies AB. Or I have to find out R1 intersection R2 implies R2 minus R1. That means C implies DE. I have to find out either C implies AB or C implies DE. Is it satisfying or not? Is it satisfying or not? That is my target. Now check the C column. In the C column you can see that both are not at all same, they are different. Yesterday I told you, whenever values are not same, there is no 2 Priyanka happen, there is no 2 1 happen, then no need to confuse. Definitely this one also valid, this one also valid, as there is no repetition. If there is repetition, then we have to check A, B and D. As there is no repetition, without checking only we can say this is also valid, this is also valid, means this one is lossless. That means this one is lossless. Clear? How to do this type of question? From the given table you have to find out, means you have to find out the dependency is present or not. Right? Those who did not watch this how to find out this dependency is valid or not, for them you have to watch the previous class. Yesterday only I have taken that class. Please watch that. Okay. Achha, now another important topic is coming. Yes. Now another important, by taking the table you have to check the dependency. Dependency is there or not. That is you have to check. Next important chapter is transaction and concurrency. As I told that in transaction and concurrency, as you can see, these protocols are very important protocols. Timestamp, strict two-phase locking, two-phase locking, and this is asking about the theories. Transaction and concurrency chapter I am not repeating again because this is theory. I am taking here all the concept. Just this question I have added. Those who did not watch transaction and concurrency protocols class, try to watch the protocol and revise it. Theory I am not going. Just tell me the answer. After that I will go for the conceptual question. Yes. Answer is definitely this one, because timestamp protocol always ensuring deadlock free. It is freedom from deadlock. And strict two-phase locking ensure cascade-less rollback. This is very important. And two-phase locking, normal two-phase locking protocol, it is actually this one key. Two-phase, only growing phase and sinking phase. In fast phase you can acquire the lock, and in the sinking phase you can release the lock. That's why it is called two-phase locking. And lock point, what is called the lock point? Lock point means it indicates the final lock of the scheduler, which is very important. Must revise all the protocol. High chance you will get question from transaction and concurrency, and I am telling you, in this transaction concurrency chapter also you can get 10 marks question. It is possible. As you can see, this type of question you can get. They will give you transaction, after that they will ask you, here they ask the order. They can ask you order, they can ask you it is view serializable or not, it is conflict serializable or not. Like this way you can get the question. So here you can see one question. Can you tell me what will be the order of execution? And in this question you can tell me that also it is conflict serializable or not. Is this conflict serializable or not? This is also you have to tell me. Okay, good. Answer is coming. Option 3 is the correct answer. Very good. Here you have to draw the graph. Okay, you have to draw the graph. After that you have to see that it is coming or not. Yes, this is called through the topological sorting you can do it. So here T1, what is the graph name? Who can tell me? Whatever graph we have to draw, what is the name of this graph? Who can tell me? What is the name of this graph? Yes. Here T1, T2, T3, T4. How to do it? Here you have to start from the first timestamp. In the first timestamp, T2 is here. T2 is reading the data. Conflicting pair means read write, write read, and write write. That should be on same data and different transaction. same data and different transaction, right? It should be different process but same data. Always same data. Data should be same. Transaction should be different. Yes. Here. Dependency graph, not at all. Precedence graph. Yes. Paramesh is giving correct answer. Satish is giving correct answer. Precedence graph. Exactly. Name you forgot, right? So here you have to find out on the X. Anyone is doing write operation after this. After this timestamp, anyone is doing write operation on X. You can see here, this is doing write operation on X. This is also doing write operation on X. So means from T2 to T3 there is an arrow. And from T2 to T4 also there is an arrow. Okay. Now you see that. Here is read Y. Anyone is doing write operation on Y. You can see here this is doing write operation on Y. After T3, T1 is doing. Means from T3 to T1 there is an arrow. Here you can see this is a write X is going on. Already we check it on X. What is going on. Here it is write Y. Already with the Y also we check who is doing it. Now here you can see this is a read Y going on. Is there anyone which is doing Y operation after this? Not before this one. Before it is going on, not here. After this is the timestamp. You have to check later. Means after this one anyone is doing write operation. No one is not doing any write operation. Here also no write operation on Y. Here whenever you are checking X, read X, anyone is doing write operation after this. This one is doing write operation on X. That's why T4 to T3 there is an arrow. T4 to T3 there is a I hope I am audible. Hello? Now am I audible? Now refresh once. Now clear, right? Yes. Okay. Okay, good. Yeah. So we have to do in degree. Here we have to do in degree. Okay. After doing the precedence graph, we have to do in degree. Now in degree means incoming arrow. Here how many incoming arrows are there? 1. Here how many incoming arrows are there? 2 incoming arrows. So it is 2. Here how many incoming arrows are there? 1. Here no incoming arrow. This is 0. Always you can start with the 0. No audio. Here no incoming. Audio is there, right? Yes. So you have to find with the where there is incoming arrow in degree is 0. In degree is 0. Here you can see in degree 0 is T2. So that's why you can start with T2. After that you will cut these vertices. Whenever you are cutting these vertices means this vertex is not present, this one is not present. As these are not present, you will update the value. Now here in degree is 0, here in degree is 1. Because already you erase this. Now this one is in degree 0 means I can start with T4 now. Now I will take T4. After taking T4, again you will cut the edge. This edge is now not present here. So cut the edge. After cutting, you will update this one. This one is now 0. So next one you can do with T3. T3 is done. Now we will cut this one. Now this is 0. Means now this is T1. According to this way you have to solve T2, T4, T3, T1. like this is topological sorting only. It is the application of topological sorting. Remember that question can come from here also. This is the application of topological sorting. From the transaction, whenever they are asking you question ki what will be the sequence, you are applying topological sort here. Okay, that is also can be question ki what algorithm you are applying. Okay, clear? I hope it is clear. Yes, now can you do this? Now can you do this transaction? This is the serializability. It is the next important, from where you are always getting question. Serializability chapter, means transaction chapter, conflict serializability. And not only conflict serializability, view serializability is also important. Not only this one, view serializability is also important. And those who are watching till now, please subscribe to the channel. I have a dream to fulfill the 35k in this 2024. Only few hours left, but we need little more. We need little more. So if you can help us, then at least this dream, like only for 35k dream in this 2024 will be complete. I was thinking ki okay, in this 2024 we will be able to complete 35k. We are in 34.8k. We are in 34.8. I hope you can help us to only few hours left, right? In this few hours, at least this 200 subscriber we need. In this 200 we can reach to 35k at least. So if you can help us to get this, I hope it will be good for us. I will get some motivation कि चलो पर आके भी कुछ होता है. I can get some motivation, because I can't do those type of marketing and all those things, means like that. Something different. Always we are following in your class, your understanding. That is only our target. That's why we are not able to reach to ultimate those types of students. But you can help us to reach actual learners, those who want to learn. Okay, try to share with all of your friends. If everyone, you all are sharing with at least one or two of your friends, then also you can help us to grow our family. Okay, so please do it. What is the answer here? What is the answer here? Yes, my daughter came and I am explaining this one. Here this one is S1 is only S1 is conflict serializable. How to do this? Here I am doing here S1 in front of you. There you can see this is S1. How to do it? Here by taking S1 you can see that sometimes they are giving T1, T2, T3. Right? T1, T2, T3, sometimes they are here. So R1, R3, R3, R2, R2, R3, like this way you can see how many numbers are there. By looking this you can understand there are 3 transactions actually. What is T1, T2 and T3. These are the 3 transactions are there. Okay. Now in this 3 transaction you can see R1X, R1X, here R3Y. Just write correctly. Don't write R3Y here. So write it correctly after the next. Leave it blank. Here write it R3X. R3X. Now R3Y. Sorry, it was not R3X. This is R3Y. This one is R3Y. After that here R3X, so R3X, then here R2Y. So here write down R2Y. Leave it blank. Don't make it here, otherwise your answer will be wrong. Then here R2Z. So R2Z. Then here W3Y. So W3Y. Leave here blank. Here W3Z. W3Z. R1Z. Leave this blank. Here you are putting R1Z. W1X. 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 Here W1Z. W1Z. Okay. 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 This is the way you should write. If your writing is correct, then your answer will be correct, because then only your graph will be correct. Now you have to draw the precedence graph. T1, T2, T3. Simply draw the precedence graph by checking the conflicting pair, read write, write read and write write. These are the conflicting pair with same data. With same data, right? So here you can see R1X. R1X. Is there anyone which is doing X? Is there anyone? Here you can see write X. Is there anyone which is doing write operation on X? No. Anyone is not doing write operation on X. This is doing read operation. So there is no. Here it is doing R3Y. Anyone is doing write operation in Y? You have to check anyone is doing write operation in Y. Is there anyone? No. I hope no. We are not getting, and I hope I did correct, right? There is no mistake. Okay. Here R2Y. Is there anyone is doing write operation on Y? Yes. This one is doing write operation. So T2 to T3 there is an arrow. You got it? Now you can see Z. Is there anyone who is doing write operation? Here this one is doing write operation. That's why T2 to T1 there is an arrow. T2 to T1. Yes. Yes. Is there anyone you are getting? After this one you can see here it is Y. Is there anyone which is doing Y operation? No. Here you can see Y Z3 and here it is doing on Z. So here also T3 to T1 there is an arrow. T3 to T1. Is it creating any cycle? It is not a cycle. Here this arrow is coming in this direction, this is going in this direction, this is going in this direction. So there is no cycle. No cycle means it is conflict serializable. Here also don't do mistake. Okay. Before R2Y in T3. In S1 W1X is there, ma'am. That we did, right? W1X. That we did, right? R1X, then R3Y, then R3X, R2Y, R2Z, W3Y, W3Z, R1Z, W3Z, R1Z. Yes, everything we did. It is not creating any cycle, right? As this is not creating any cycle means it is conflict serializable. Here also, husband and wife. You did the mistake, you did the mistake. You did the mistake, you did the mistake. You are the ultimate culprit, you are the ultimate culprit. If like this way the cycle is going on, it is a never-ending fight. It is a never-ending fight. Means whenever cycle is there, you will be not able to break the cycle. Serial means what? Serial means you have to make it like that. Just now what you did. Here you will be make it serial. How? What is the serial schedule here? Here in degree is 0. here in degrees 2, sorry, here in degrees 2, here in degrees 0, here in degrees 1. That's why you can make it serial, like T2 will do fast. After that you will eliminate this one is 0, then T3, then T1. This is called serial. Means you are able to make them serially you can arrange them. First T2 is doing work, then T3 is doing work, then T1 is doing work. You are able to make it serial. But between this type of transaction, you will be not able to make it को चलो पहले वाइफ कर लो फिर हस्बैंड, पहले हस्बैंड कर लो फिर वाइफ. ऐसा नहीं होगा, क्योंकि दोनों को बोल रहा है कि you did it, you did it, you did it, you did it. It is a never ending fight. That's why conflict is there. Don't focus on the word conflict. Problem is that students are focusing on the word conflict. हर घर में झगड़ा होता है, ये दिस इज नॉर्मल. हर घर में झगड़ा होता ही है. conflict will be there in every family. There will be conflict between everyone. But the problem is there, झगड़ा सुधरते ही या नहीं. Someone should stop. Conflict should stop. You are able to stop the conflict. You are able to make them serial or not. When it is not creating cycle, means someone silence. Okay, I will not blame. I will not talk. Wife is continuously telling, husband is stop. Means now their conflict is stop. So conflict is stop means okay चलो पहले आप कर लो, पहले आप ऐसे हो रहा है तो बंद नहीं होगा. तो किसी को स्टॉप करना है. ओके आई एम स्टॉप ब्लेमिंग. सो ओनली वाइफ इज ब्लेमिंग द हस्बैंड. You did it. Husband is not blaming. So what will happen? As husband is not blaming, so that's why पहले आप करो, वाइफ पहले कर लो, हस्बैंड बाद में करो. ठीक है. नो साइकिल. No cycle means conflict is there, but you are able to make it serial. That's why it is conflict serializable. But whenever cycle is there, you will be not able to make them serial. That's why then they are not conflict serializable. Conflict is there, but you are not able to make them serial. Conflict is there, but you are not able to make them serial. That's why it is called not conflict serializable. Got it? Never do the mistake. With these words you are getting confused. The word is making you confused. You are focusing on the word conflict. Never focus the word in conflict. Focus in the word serializable. झगड़ा होता है, conflict होगा, but after the conflict also, if the cycle is not there, you will be able to make them serial. That means it is serializable. If the cycle is there, you are not able to make them serial, means it is not serializable. I hope it is clear. इसके बाद अगर अच्छा लगे तो like, share, subscribe and please be connected with Unified Study family. I have a dream with a 1 million subscriber. So please make our dream true without any clickbait video, because we don't want to make any clickbait video. This is that is okay. Exam postponed, exam cancel, एग्जाम फिर से होगा, एग्जाम दोबारा होगा, क्या एनटीए के ऑफिस जा रहे, क्या सब होता है ना कि चलो एनटीए के ऑफिस चलो, फिर से एग्जाम होगा, एग्जाम पोस्टपोन्ड होगा, ये गलत आया है, वो हुआ है, ये हुआ है, ये सब करके हम लोग को नहीं लेना है सब्सक्राइबर. We don't want subscriber like that. We want valid subscriber, those who actually want to learn, those who actually want to join with Unified Study family. We are going to start the new year 2025 with new resolution, with new way of learning, with new way of strategy. Our course is coming from tomorrow. Tomorrow morning you will get the new course going to launch. Definitely today night only we are launching the new course with new energy, new strategy, new everything. Those who want to join, you can join. Discount will be there for first 1 week. There will be the discount, 25% discount you will get. We will share that coupon also. Those who want to join, those who want to start 2024 course with us. You can join with us. We will share that soon. So bye everyone, and I wish to meet you all again. Maybe in this next year, right? एक साल के बाद फिर मिलेंगे 2025. Okay. Goodbye everyone for now. 2024 ending class. Let's see if I can come, because I want to spend time with you. Let's see if I can come again. I will come, or again we will meet tomorrow. Tomorrow एक धमाका होगा, ठीक है? Be ready for the 2025 dhamaka. Tomorrow will be a dhamaka. Tomorrow my family members, my husband and my daughter is going to picnic, and we will do a marathon tomorrow. One dhamaka will be there tomorrow. ठीक है? चलो, advance happy new year to everyone. Please fulfill our dream. Only 200 remaining. Please help us to complete this 200 target. Please help us to complete the 200 target. 35k at least. This is very minimum. We are in 34.8. 200 remaining. Please fulfill the dream. Thank you. Bye. See you again. 1 year. एक साल के बाद 2025 we will meet again. Bye. Bye. Happy New Year to everyone. Advance Happy New Year to you and your family. Be happy. Be